that last recording got cut off just at the end, so let me pick up here where we left off. We were doing this formula for example 4, and here's the solution to that. And I am going to make one correction to all the, or formatting change rather, to all of the values in this column, because I really like to see numbers, decimal places I don't think we'll need in any of these, and I would really like to see this thousand separator. Makes them much easier for me to understand. Okay, quickly work through the last few examples here for you. Example 5. Okay, and we're told that what we need to calculate is n, choose r, which if we just write it out without doing any calculation on it is n over n minus r factorial times r factorial. And we're given a few things in this problem. We're given n. Oops. Excel is kind of cool in that it automatically fills things for you, but sometimes you don't want them to fill, so you have to delete it. And n is 49. And we're given r, which is 6. And so we know we're going to need n factorial, so let's get that. Fact b 28. That's a big number. R factorial, or wait, yes, we do need R factorial for this one. Okay. Fact b 29, small number. And we're going to need the quantity n minus r. So let's just do this really basically every single step here. N minus r is b equals b 27, not 27, 28 minus b 29. Yep. And we're going to need that factorial, so n minus r factorial. So that's equals fact b 32. Now, I know when people first learn this kind of work in Excel, the different cell references can be kind of confusing. So for this one, for example, look up here in the formula bar, why not just do 49 minus 6? Well, you could do that. But if you made a mistake in typing the 6 in, you might not realize that. And since you'd have to look up here in the formula bar or go into the cell to figure that out, that could just make it a little bit harder to figure out what you did wrong. And then the other thing is that when you lay this out sequentially step by step so that you're entering in the givens, and then anything that's calculated after that, whether it's factorial, a big number like this one, or a small number like that one, or just a simple subtraction even, then when you go to put the whole thing together in the end, it's a little bit easier. So what I've done is set up all the pieces that we need for the final solution. So now all I need to do is n factorial, which is b 30, that big number, divided by, and I've actually done, if you look in the book, they show you the intermediate step that we've already done with 49 minus 6. So we already have n minus r factorial. So n minus r factorial is b 33. b33 and times r factorial, which is b31. And that looks like the right answer. Okay, now just to make a point about the parentheses, I always like to put in parentheses when there's division like this, when there's a denominator that has some sort of operation going on, multiplying something by something else or dividing something by something else, or if that's happening in the numerator. And this is probably obvious to a lot of you, but that will matter sometimes and sometimes it won't matter. In this case, it will matter. So if we take this out, it's a different answer. 7 million, not million, 100,000 millions, billions, trillions, 7 trillion and something. But the point being that because of the order of operations, now what this is doing b30 divided by b33, and then that quantity times b31, whereas with the parentheses is doing b33 times b31 first, and then dividing b30 by that quantity of those two things multiplied together. So really important to pay attention to those parentheses, and it wouldn't matter in other examples. For example, if the things being multiplied together were in the numerator, in this case it would work those two things first, and then by the time I got to the division, it would do the same order as if the parentheses were there, but in this case it really does. So I always just like to keep them in to keep things clean. Okay, let's do example 6, which is our last one. And you should be getting a good feeling for how to do these things in Excel, but feel free to post or email any questions about how to do it. This one's a little bit more complex, but not too bad. We're going to do an NPR, which is n factorial over n minus r factorial. And then we also have to do NCR, but we actually have done that above, so why don't we just copy the formula there. That's A27. Yeah. And here's actually another neat little trick. If you just copy that cell, now what you see in the cell is NCR, but what the cell actually has in it is A27, and you can see that up here. So if I copy it from here to here, it's actually going to follow the logic of the copying. So since I copied it one to the right, it's now going to, instead of referencing N27, it's going to reference B27 and give me this. So it's actually copying from here to here. That's a nice little shortcut trick. And so we have, what are we given here? We're given, do a little bit of a shortcut here, even though when you're doing homework for the first time, I recommend that you write out all the given elements instead of the calculated elements. Because if I were doing homework here, and right now I know that, let's see, fact 8, okay, I have that number. If I sort of, did that n factorial calculation somewhere else, wrote in the number 40,320, it would be really hard to backtrack if I get a wrong answer. But since I'm doing it in Excel, I can put in the formula for fact 8, and then if I need to, if I get a wrong answer, I can go back and say, well, wait a minute, what did I factorialize? Oh, I factorialized 8. Okay, n is 8, and that's the right thing to do. But you have to take a little bit of an extra step. It might be easier if you just type in n, and then for n minus r, that's quantity, quantity factorial. That's going to be fact, and the number that we're putting in here, is now 8. again, I could just type in 5, but this gives me a little bit better backtracking in case I get a wrong answer. And then for the solution, it's n factorial, which is b40, b39 over b40. And it looks like we did that one right. For the second one, it's the same given elements. So we've got n factorial, we got n minus r factorial, but now we add on to that r factorial. We didn't have that before. Actually, make a note here, solution A. We're going to add to that r factorial, which we didn't have, and r is 3. So fact 3. That's an easy one to do. And then solution. Solution B equals. Let's see, n factorial b39 over n minus r factorial b40 times r factorial, which is b43. Looks like we did it right. Okay. Now, if you notice here where I'm clicking, we actually used this formula before. So let's see if this works. I typed in the formula again. That's good practice. But let's say I didn't want to do that, and I know I used it before. So solution B, and I noticed that. Why? Because here, this guy is the same thing we just did up here. So I know I did that before, and I go, oh, I've done that before. Where did I do it? Okay, I did it here. Where's my solution? I did that. If I take this guy and copy this, this won't work just right, actually, the way I've got it set up. Right. So the reason it doesn't work is because the cell references are different. See, it's got the right formula in there, but it's referencing different things above. And if I had set up example 6b to look just like this with the same rows and the n's and the r's and the n factorials and r factorials all in the same places, it would have worked, and I could have just copied this down here. It would have calculated because the right thing, because it was drawing from all the same places. But in this case, it doesn't work, so I would have to go in and edit it again to get the right answer. I'm going to do that so I don't think that that is the right answer. Okay, I hope that's helpful.